can practice these next few problems using your calculator. I'm not going to stress these to a great point, but for example, if you're typing 3 square roots of 11 into your calculator, you'd want to make sure that you type it in as 3 to the square root of 11 and make sure that that exponent is inside of parentheses, and then make sure to get your answer out. And you don't need a graphing calculator to do this. You can do this with a regular scientific calculator. I would make sure that you can do these, but it's not that huge of a deal. Continuing along, another exponential graph or function that we see a lot is the function y equals e to the x. And this e gets used a lot. E is kind of like pi. It's an irrational number that we see a lot. It continues on forever. Remember, pi is the number 3.14359, keeps on going. Well, the number e looks like 2.718. And so we don't actually care what the actual number is, but it is important that you know that e here is about 2.7, because then that means that its base is bigger than 1. So what that means is if its base is bigger than 1, for graphing, it's going to have the exponential graph that is going like this. It is increasing because the base is bigger than 1. So let's look at an example of a couple of functions that are exponential graphs, and let's graph those. So let's look at problem A. Let's look at how to graph y equals e to the x. Well, because e is about 2.7 something, we know that it's bigger than 1. It means that it will have the increasing graph. Well, we already said that no matter what our function is, whether it's e, 1/3, 2, whatever base it is, anything raised to the 0 is 1. So e to the 0 is 1. We'll definitely go through that point. We're not shifting this thing left or right or anything yet, so we know we will have an asymptote, a horizontal asymptote at 0. And we know we're going to follow this increasing pattern for our graph. Now, I've only got 1 point here, especially because of my math lab. Let's do more than 1 point. Let's also plug in a point to the left and to the right of the 0 point. So we'll plug in, let's say, -1 and +1. Well, if we plug in +1, let's do this over here, we will get e to the first power, which is about 2.7. So that means if I were to graph this as a point, if I go over to 1, I'd be up at about 2.7. And that also means if I plug in, let's say, -1, I'll get e to the -1, which is 1 over e, which is about 1 over 2.7. Well, 1 divided by about 2.7 is about 0.37. So that will be somewhere over here if I'm plugging in -1. And then I can fill in my increasing graph. And that's good enough. That's really all I need for either graphing this by hand or in my math lab. So notice my domain is just as before. It goes left and right forever. So my domain is -infinity to infinity. Notice my range. My graph starts here at 0 on the y-axis and then goes up forever. So we'll have 0 to infinity. But as a reminder, we have an asymptote, a horizontal asymptote here at 0, so it's going to be a parentheses, not a bracket, at least at 0. Infinity always has a parentheses, so no matter what, that will be a parentheses. Notice, when is this graph increasing? Well, if we trace this graph from left to right, using a pencil or a pen, notice it's always going upward, which means it's always increasing. So on its entire domain from negative infinity to infinity, it is always going up. It is always increasing. When is it decreasing then? Never. Let's look at problem B. In problem B, we have y equals 3 to the negative x. Well, remember, let's take a look at this. We've got a negative exponent on our 3, which means I can rewrite that 3 with the negative exponent as its own little fraction. That negative exponent will drop the 3 down to the bottom, which would leave a 1 up on top. But when it does that exponent, that x that was our exponent becomes from a negative exponent, it will turn into a positive exponent. So what the negative exponent did was create a fraction. So it actually made my base, which looked like a number bigger than 3, it now is clear that it is not. The base is 1/3, which means the base is going to be less than 1, which remember, that's going to be the graph of the exponential will be going downward, which means it's now going to be decreasing because the base is less than 1. Okay, well, I still need to graph some points here. Well, we know that if we plug in 0, anything raised to the 0 here for your x, if we plug in 0 for x, will be 1. So plugging in some points, if we plug in 0, we get out 1. Well, what happens if I plug in 1? Well, if I plug in 1 for my exponent, I get 1/3 to the 1, which is just 1/3. So plugging in 1, I get 1/3. Plugging in negative 1, I get 1/3 to the negative 1, which would flip the 1/3 and turn it into a 3. So if I plug in negative 1, I get out 3. Now, just as always, we have that horizontal asymptote at 0. And then I can fill in my graph, which we said was decreasing because the base is less than 1, and our points match up with that. So it's not perfect, but there it is. Let's look at our graph. What's its domain? Well, notice it goes left and right in both directions forever. So negative infinity to infinity. And just like the last graph, it starts at 0 and continues on upward forever. So we'll say 0 to infinity. Again, because of the horizontal asymptote here at 0, we're going to use a parentheses. And we will use a parentheses at the infinity like we always do. That never changes. Now, when is my graph increasing? If I were to trace this graph, when is it increasing? Well, let's see, if I trace my graph from left to right, notice it's always going down. It's always decreasing. So I'm going to say it's decreasing from negative infinity to infinity, which means when is it increasing? That would be never. So that's always going to be our case for our exponential functions. Either they're always increasing or they're always decreasing. They can't ever be doing one with it one way and one with the other. It's either always increasing or always decreasing.